Think about this. If light had discipline, it would look like a laser. Every part of it aligned, moving together, perfectly controlled. No randomness, no chaos, just pure order. But how do you force something like light to behave this way? To understand the problem, we first need to know what a laser actually is. Most light in the world is chaotic. Photons move in different directions with different timings and no coordination. A laser changes that completely. Inside a laser, atoms are forced to emit light in a very controlled way. Each photon that's created becomes a copy of the previous one. Same direction, same energy, same timing. So instead of randomness, you get a beam where everything is aligned and synchronized. Not just moving forward, but moving together. This synchronization is the reason lasers feel perfect. Because everything is in sync. The beam stays narrow, the energy stays concentrated, and the direction remains stable. Comparing to normal light, which spreads instantly, a laser behaves like a single unified beam. At this point, we almost feels like we have created a perfect light. But it's not. Light isn't just particles, it's also a wave, and wave follows a rule that they can't escape. They spread out over time. This is called diffraction. No matter how perfectly aligned your laser is, the moment it leaves the source, it begins to expand. Not because something went wrong, but because it has to. So if we have a diffraction, and it is unavoidable, why are lasers still so precise? Because organization delays the effect. Normal light spreads immediately in all directions. Laser light starts aligned, so it spreads slowly and predictably. That delay is everything. It allows the beam to travel long distances before it noticeably loses focus. So lasers don't break the rules of physics, they just hold their structure longer than anything else. If the beam is spreading, why not just make it stronger? More power, more energy, a tighter, better beam, right? But here's the surprising part. Increasing the power doesn't actually solve the problem. Because the spreading of a laser has nothing to do with how strong it is. It comes from something much deeper. The fact that light is a wave. And waves don't care how powerful they are, they still spread. In fact, pushing more power into a laser starts creating entirely new problems. The air itself begins to react, heat builds up, the beam starts distorting its own path. So instead of fixing the beam, you are now fighting the environment around it. Which leads to a strange conclusion: more power doesn't make a laser more perfect. And yet, despite all this spreading, lasers can still travel enormous distances, even all the way to the moon and back. So what's going on? The key isn't that lasers don't spread, it's how they spread. Normal light expands in every possible direction almost instantly, but a laser spreads in a very specific way. Instead of exploding outward, it slowly opens up into a narrow cone, which means two important things happen at the same time. The beam is getting wider, but it's not losing its direction. So even after traveling huge distances, you still know exactly where it's going. That's why lasers are so useful, not because they stay perfectly straight, but because their imperfection is controlled and predictable. Laser light isn't special because it's stronger or brighter. It's special because it's organized. Every part of it moves together, aligned, synchronized, and controlled. And even though it can't stay perfectly organized forever, that initial order changes everything. It allows the beam to stay focused longer, travel farther, and behave in a way normal light never can. So a laser isn't perfectly ordered, but it's the closest we have ever come to controlling light itself. And that's what makes it so powerful.